Good evening, ladies and gentlemen. Welcome to Envic-Senses live stream from Visby, Gotland, Sweden during Almedalsveckan, Almedalen Week 2018. My name is Eva-Lena Gårdhagen. I am the CEO of Envic-Sense. Today we are happy to present our instrument FREEDD. FREEDD is an instrument for detection of and quantification of toxic compounds in water and soil. The acronym FREEDD stands for Field Real-Time Environmental Detection Device. And now I'm happy to introduce Peter Gårdhagen, CSO and CTO at Envic-Sense, to perform the presentation.
To provide clean water and clean soil to humanity. To provide clean water and clean soil to humanity is one of the biggest challenges in our time. Historically, drought and toxic water has been a major problem in the third world. However, shortage of clean water due to pollutions and climatic changes afflicts our daily life all over the world. Groundwater is one of the most important resources of clean water. However, in just a few years, essential changes to the groundwater levels is an everyday situation also in our Nordic and Scandinavian countries, where we are used to appreciate clean water as something everlasting in our lives. This luxurious lifestyle must be considered to be changed. We cannot afford to regard the water as something we can use forever without cherish its resources. We must have access to clean water to drink and clean soil to grow our crops on for our survival. We have polluted the earth for a long, long time, and unfortunately we continue to pollute our environment. For the survival of humanity, this must come to an end. The access to clean water and soil decreases at a rapid speed, which means we have to increase cleaning of contaminated water so people and animals will have something to drink. We also need to clean soil so that we can grow crops that are not poisonous to eat. Cleaning water and soil is a part of the solution, of course. But perhaps more important is that we do not continue to pollute. It's therefore extremely important that we clean all our emissions. The methods currently available for cleaning need to be improved, and we need new, more cost-effective methods. There is already extensive research going on. For example, how contaminated water is to be purified and how polluted soils can be made useful again and how we can clean our emissions. But regardless of whether we use today's methods or of purification or tomorrow's methods, the need to easily and quickly measure pollutants is of great importance, not only because we know that it's clean enough, but also to keep the costs of cleaning processes as low as possible. Today's most common method of knowing whether a water sample or a soil sample contains toxic substances such as mercury or cadmium is to send the samples to a laboratory. This means that in the best case you have the test results the following day, but usually you have to wait several weeks for the answers. There are many applications where you do not have that time. You need the test results immediately. For example, checking of drinking water, where you must know at once if something is happening to the quality of the water. Another example when access to rapid test results are important is in the various treatment processes. For example, at power plants, where large amounts of smoke is cleaned with water and the water must be purified before being released into the nature. Usually expensive cleaning processes are included to ensure that, for example, no heavy metals are released to the environment. these purification steps must be monitored on a daily basis so they are working correctly and are not replaced more often than necessary. With the availability of simple and quick analysis of toxic substances such as heavy metals, purification processes can be run, optimized, and large costs can be saved. A third important area where access to rapid test responses is important is in the treatment of contaminated soil. Today, most common method is to remove dangerous soil and replace it with clean soil. This method is expensive, of course, and you do not want to excavate more than necessary. With forthcoming methods where hazardous substances will be destroyed or made harmless in the soil without the need for replacement of the soil, there is also a need for rapid test responses so that no more chemicals than necessary are used with high costs as a consequence. Simple, fast and safe measurement methods for water and soil samples are requested more and more to know how polluted it is and to know if we are running our cleaning processes as cost effective as possible. This is FREEDD. FREEDD, as you see, is a quite small instrument. This is FREEDD and it's connected to a computer. And you see the interface between the operator and the system is quite simple. It has only two buttons on it, one for start the instrument and one to start the pump in the system. All other interface is connected by the computer. Since we are talking about very low contamination levels, it's a need to be very careful so you not contaminate your samples, and you need a certain method of design of the instrument to be able to take the instrument out from the lab. This small piece here, the measurement cell as we call it, it's the invention that makes it possible to take the instrument out from the lab into the site, into the lake, to the factory, wherever you want to perform your analysis. This measurement cell contains the sensor, and as you can see here, there are some channels that makes a loop, and here is a pump. The measurement cell will be filled with liquid, and when the pump runs, the liquid will circulate in the channels, so it's a continuous flow cell. This measurement cell will be used for between 5 to 10 samples before it will be replaced with a new one. The use of these measurement cells makes it possible to go into the field because you will always guarantee that you start with clean performances, with clean conditions, and you do not have to clean anything after the analysis. You just change the measurement cell for a new one, and you can use it between 5 to 10 times. The instrument is based on QCM technology, which will be introduced in a short movie.
FREEDD is based on QCM technology. QCM stands for Quartz Crystal Microbalance. By exposing a quartz crystal for electric energy, the crystal begins to oscillate with its own frequency. Its own frequency depends on the crystal's mass. If the mass increases, the frequency will decrease. By treatment of the crystal surface in a certain way, you will have a sensor selective for a specific substance. When the target substance fastens on the crystal surface, the mass increase, resulting in a deviation in frequency. The deviation tells us that our target substance is present in the sample, and it also tells us level of concentrations present in the sample.
And here follows a little movie that shows how the instrument can be used for on-site analysis of water samples. Everything I need in order to perform a qualified water analysis is in this suitcase. Here is the instrument, FREEDD. I have a laptop, a cable connect between the instrument and the laptop, gloves, a fresh measuring cell, syringe, liquid to fill the measuring cell with, and a bottle to take the water sample. I can use the suitcase as a stable board for the instrument, and the first I do is to connect the instrument with the computer. And since we are talking about rather low concentrations of heavy metals in water samples, we need to use gloves in order to avoid contamination of our cells or the test samples. The first thing I do is to fill the measuring cell with some liquid. It's very simple to do that, just like this. You close the valve, take the syringe out, and put the measuring cell into the instrument, turn the instrument on. And now the software is running, and you can see on the display here that you have a straight blue line indicating that everything as it should be. At the bottom of the x-axis is the time schedule in seconds, and the y-axis is the deviation in frequency. And the system is running. And now I turn the pump on, and the liquid starts to rotate inside cell, and I have to wait a few seconds before the system is stable again, as it is right now. And now I can take the sample and inject into the measuring cell 100 microliters, like that. And then look at the display and see if anything happens. And here we have the curve. The first part here shows how stable the system is before we have injected a test sample. And here we inject the test sample, and after 10-15 seconds the curve starts to rise, indicating that the salt substance is present in the test sample. And a level here before the curve stabilizes again indicates the concentration in the sample. Today we have measurement cells for arsenic, cadmium, lead, and also for mercury. And we have also a measurement cell for TNT and explosive. For more information, please contact us at www.envic-sense.com. Thank you.